Hi everybody. We are going to talk about factoring polynomials. Now this introduction is going to basically be one part of factoring polynomials. It'll just be determining the greatest common factor of a polynomial. So the learning target, today I will examine the terms of polynomials so that I can factor polynomials completely. So think about it. Could you do the distribution in reverse? Distributing versus factoring. Now, when we distribute, you're multiplying. So 2 times the quantity of x minus 5. So of course, we multiply 2 times x. And in this case, minus 2 times 5. 2 times x, 2x, 2 times 5, 10. Of course, the minus sign, that separates the two terms. Now, what about going to in reverse? So we have, now we need to factor 4 times y plus 12. So now we need to figure out what factors multiply to equal 4y and 12. Well, we need to figure out a common factor. So turns out 4 and 12 are both divisible by 2. That's obvious. We can do that. And that, we can divide by 2. Divide by 2. So then you get 2 times 2y plus 6. That's not bad, but we want to try to find some number that is even larger than 2 that we can divide into both 4 and 12. And 2 is not a bad guess, but turns out 4 is a larger number than 2. So what if we tried 4? So 4y divided by 4 and 12 divided by 4. Let's try that. Well, 4y divided by 4. Remember, these guys, the 4 on top cancels out the 4 on the bottom, so you're left with the y for the first part of the first term, and then 12 divided by 4 is 3. So in the end, that's how we have the result of 4 times the quantity y plus 3. Now finding the greatest common factor of a polynomial. Greatest common factor, that's the GCF. So that will be what we will call the greatest common factor. We're going to abbreviate it as GCF. So now we want to look for, anytime we factor a polynomial, we want to find the GCF of the coefficients. Remember, your coefficients are, in this case, 12, negative 28, and positive 8. Now, for factoring purposes, we're just going to use the positives. So we're going to use 8, 12, and 28. So we gave you a list. Turns out, gave you the list of factors for 8. 1 times 8, 2 times 4. And factors of 12, 1 times 12, 2 times 6, 3 times 4. We try to place them in numerical order from least to greatest. And then factors of 28, 1, 28, 2, 14, 4, and 7. And we've highlighted the 4 because the 4, or in this case we circled, The 4 is the greatest common factor amongst the 28, the 12, and the 8. Now, when you look at the variable part, you have to look for an x cubed, x squared, and x. You have to look at what is the smallest exponent. The smallest exponent out of x cubed, x squared, and x is 1. So it's the 1. So in this case, out of the 3 variable parts, the smallest exponent is x. So that's how we determine the GCF of these 3 terms, 8x, 28x squared. Well, actually, this will be 12x cubed. So that would be 12x cubed. So the greatest common factor is 4x. Now there's another way you could determine the GCF of your coefficients. You can use Desmos. So for Desmos, actually, let me type it in. That might be easier. So what we're going to do, we're going to type in, here's a little Desmos hint for you guys. Desmos command. GCF, actually, should be in lowercase. GCF of, and then just type in your numbers, 8, comma, 28, comma, and then you would hit your enter sign, and then you would get the result of 4. So that might be a way to help you determine what your greatest common factor is. So now when we go to once we find our greatest common factor, which is the 4x, now what we're going to do is the following. We are now going to, once we factor our GCF, we're going to divide each and every term of the polynomial by your GCF. So the 4x, which was our GCF, so in this case, that was from the previous slide. So GCF is 4x. So that was from the previous slide. We divide 4x by each term. 12x to the third, negative 28x squared, and 8x. So after we do the 4x, you're going to keep your polynomial, but divide each term by the 4x, or your GCF. And then you simplify each division portion of your polynomial. So for instance, 12x cubed divided by 4x, that's 3x squared. Negative 28x squared divided by 4x, negative sign you keep. 28 divided by 4 is 7. X squared divided by x is just x. Just remember, subtract your exponents. 2 minus 1 is 1. So don't forget, that's a 1, 1. And then for the last case, plus, keep your plus sign. 8 divided by 4 is 2. Now, x divided by x. 1 minus 1 is 0. So in the end, this x term goes away. Make that a little neater. So now we're just left with 8 divided by 4, and you get 2. Now this is the reverse box method. Again, You can always use the box method to check. So 4x times 3x squared, 12x to the third. 4x times negative 7x, negative 28x squared. 4x times 2 is positive 8x. So that's a way you can check whether or not you factored the GCF properly. These two problems, I want you to try on your own. You can, so now your first question is, in this case, what is your GCF? So if you want, in Desmos, type in the following. GCF 15, 18, don't worry about negatives, 30. You should get a result of 3. And then smallest exponent is, well, out of 6, 4, and 2, the smallest exponent is 2. So in the end, GCF equals 3y squared. So once we'll that is how. So I really should have wrote here x and then your exponent of 2. Or I meant y. Whoops, no. And it should be a y. And then what you would have to do in your last step, of course, you need to divide each and every. If I can, hold on. Sorry about the delay here. So that's your GCF, but now you need to divide each and every term. 15y to the 6th minus 18y to the 4th plus 30y squared. You need to divide it by 3y squared. And that's how you, so that's your GCF. And then you would do your division. And the result of this problem should be, once we get, 3y squared times, well, 15 divided by 3 is 5. And then y to the 6th divided by y squared, y to the 4th minus 18 divided by 3, 6. Y to the 4th divided by y squared is y squared. And then last but not least, 30y squared divided by 3y squared is just 10. No y. Y squared divided by y squared is 1. So do not put the y for that last term. Similarly, for the second problem, you do for Desmos, GCF 6, 12, 22. That equals 2. Now, your smallest exponent, in this case, it's a to the 0. Which, in that case, a to the 0, which just means that's 1. You don't have a variable in this case because of the last term. That's why here, smallest exponent, 8 to 0, that's 1. So your GCF of the overall polynomial is just 2. So therefore, your final results will be the following. 6a squared divided by 2. 6 divided by 2 is 3. A squared divided by 1, just a plain old a squared. Sorry about this delay here. Sorry, the font was acting funny. Nope. Try again. Sorry about that. There we go. Third time is the charm. Negative 12a divided by 2. Negative 6a. And then positive 22 divided by 2. Positive 11. So, in fact, these, well, I'm going to highlight our final answers in red. So I should have done a highlight for, I should have done the red as our final answer for both this problem and our original problem. Oops, sorry about that. Oh, let's redo that. There we go, a little better. Sorry about this. There we go. So those would be our answers. The final result is in red. That represents the answers for factoring the GCF of each polynomial. Sorry about that delay. Thank you for your patience. So there will be some videos that I will post that will also be through the Google Slide document that accompanies this video. So for the last slide, that's just more practice problems. Again, you're not required to do these, but you can practice. If we look at these 5 problems, again, for number 1, you're factoring both a coefficient and an exponent. Look at your variables. Number 2, again, look at your 2 coefficients. Look at your variables. 3, same thing. 4, be careful. You have an x and a y, so ask yourself if you are factoring any variables. Might just be coefficients. And then for 5, you have 2 variables. Similar to just a single variable, you need to look at the lowest exponent for each variable. So besides your coefficients, look at lowest exponent for your A's and your lowest exponent for your B's. So those are the hints for you as you try to complete these problems as you factor the GCF of each polynomial. Again, thank you very much. And if you have any questions, feel free to contact me by way of email. Thank you again. Good luck.